Right, we will be discussing the solutions to your review quiz 3. For number 1, we have an integral, and we are trying to integrate x cubed minus 3x. So when we go through our integration process, we have x to the 4th over 4 minus 3x squared over 2 plus c. So that looks like we're going to get answer choice E. Okay, for this next problem, we are finding the value of the derivative at the point 1, 0. So starting out, we're going to take the derivative of y, which is 1 dy dx, equals, and a little bit of review here, if we do the derivative of the natural log of something, then we said that if we had the derivative of the natural log of stuff, and we call this family-friendly S word here, stuff, then we would get stuff prime. So we have stuff prime over stuff. So using that, coming back over here, our stuff prime over stuff, well, the stuff that we have is x squared plus y squared, and our stuff prime is going to be 2x plus 2y dy dx. Again, we took the derivative of y with respect to x, and now let's evaluate our dy dx at the given point 1, 0. And at that given point 1, 0, we have 2 times 1 plus, but our y value is 0, so that's going to be 2 times 0 dy dx, which is great. That's just going to wipe all of this out, turns that one part to 0. Then we have 1 squared plus 0 squared. So hopefully when we finish working this out, we see that we end up with 2. So we have answer choice D. Okay, our next problem is a limit, and we always start out with a limit by trying to do our general substitution. If we substitute in 0, we get 1 minus, well, cosine of 0 is 1, and 1 squared is 1, over 0, so I have an indeterminate form of 0 over 0, so we've established 0 over 0. Now we need to move to L'Hopital's rule, and with L'Hopital's rule, we do the derivative of the top and derivative of the bottom to see, well, what do we end up with? Well, the derivative of cosine squared is, we're going to have to do chain rule here. So I have the negative, well, and of course the derivative of 1, 0, I kind of glanced over that. But we're going to have 2 times cosine of 2x to the first power times the derivative of the inside, which is negative sine 2x, and then finally the derivative of 2, or 2x, which is 2, and all of that is over 2x squared, or just 2x, sorry. And so let's see, what can we do with this? Well, if I substitute in 0 as it is, again I get 0 over 0. So let's see, we can cancel out some negatives and cancel out a 2. And so looking at our limit as x approaches 0 once more, I have 2 cosine 2x sine 2x, and that's all over x. And again, we do have a trig identity we could use here, but we're going to just keep looking straight forward, plugging in our 0, and again we get 0 over 0. So let's apply L'Hopital's rule one more time. Let's go through that again. So I'm going to note that I'm doing L'Hopital's rule one more time. So I have the limit as x approaches 0, and that 2 is just going to sit there. It's just a coefficient, and we need our product rule. So I need the product rule using sine and cosine. So our product rule says our first, so we have cosine 2x times the derivative of the second, which is going to be cosine 2x, and then plus the second sine 2x times the derivative of the first, and the derivative of the first is going to be negative sine. And I think I forgot my 2 on that first part, so I'm going to have to go back and put in that 2. We have sine 2x, and that was a negative, times 2. And let's go back because I did forget to take the derivative of the angle here, so I'm going to squeeze in a 2 right there. And of course that's all over 1. Well, if we go to substitute in now our 0 value, everything over here turns into 0, so that's nice. And again, subbing in, cosine at 0 is 1, so I have 2 times 1 times 1 times 2, so my answer is 4. And that's going to be answer choice E. Right, for our next problem, we were looking for acceleration at time 4, and we're given the position. So I need the second derivative. Now our first derivative as prime at t, that's going to give us our velocity. And a lot of people here got messed up and they just substituted in here and got answer choice E. That's your velocity at time 4. We need our acceleration. So we need the second derivative, and that second derivative is 2. It's constant, so I have answer choice B. Okay, for this problem we have, it looks like the definition of a derivative. And so let's very quickly review. The definition of that derivative did involve a limit. And so let's see, let's get this pen fired up here. So we have the limit as h approaches 0, and that h was the distance between our 2 points, of f of x plus h minus f at x all over h. And so that was just our general definition of a derivative. Now we're told in this particular problem that our function is e to the x, and we're looking for f prime at e. So f prime at e, that means, well, this is telling me that I need to replace my x value with e. So f of x is also e to the x. So notice that I need to have e to the x sitting here where f of x is, and then I need to replace my x value with that e. So looking at my answer choices, it looks like the only one that has made the correct substitution here is answer choice E. All right, for the equation of the line tangent to this function at the point of its inflection. So point of inflection, or possible point of inflection, deals with your second derivative. So let's find that. Well, our first derivative is 3x squared plus 6x. And so our second derivative is going to be 6x plus 6. To find that point of inflection, or possible point of inflection, you have 6x plus 6. And setting this equal to 0, x is -1. And we do need to verify a sign change, but we can do that very quickly with our graph. Our y-intercept is here at 6, and there is going to be our x-intercept at -1. And if we do a quick sketch, we do see we have a sign change here at -1. So there's my point of inflection, and then I need to find the y value that goes with that. And our y generator is always our original function. So we have y equals -1 cubed plus 3 times -1 squared plus 2. And so that tells me that y is going to be 4. So remember our equation of our tangent line, we have y minus 4 equals, now I've not found the slope yet, and x minus -1, so x plus 1. So now I need my m. the m generator is your first derivative. So go back to your first derivative and sub in your x value of -1. So my slope here is going to be 3 times -1 squared plus 6 times -1. So it looks like I'm going to end up with -3 for my slope. So now we have all the pieces we need to finish writing that equation. So we have y minus 4 equals -3 times x plus 1. So y is going to be equal to -3x minus 3 and then plus 4. So that looks like we're going to have answer choice B. Right, number 7, we are looking for the derivative here, and we need our product rule. This is the product of two things going on here. We have x times the natural log of x squared. So product rule, so we have f prime at x is going to be equal to the first times the derivative of the second. And the derivative of the second is stuff prime over stuff. And then plus second times the derivative of the first, which is just 1. So here our x's cancel with x squared. So I have 2 plus the natural log of x squared. So it looks like the right answer choice here is going to be B. Hey, for number 8, we have to really pay attention to what each part is telling us here. Now, the first thing that we're told with this, we do have the graph of f, so that's important to take note of. And notice that we're told that dy dx is positive. So if dy dx, our derivative, is positive, then I know f is increasing. So let's look at our graph and see that f is increasing from the interval from A to C. So automatically I know I cannot have answer choice 3. Excuse me. Now let's look at our second derivative. And our second derivative, we're told that is less than 0. So that means f is concave down like a frown. It's frowny. Oh no, frowny face. So where over what interval would we be concave down? So it's either from A to B or B to C. And we need concave down. So which one's starting to look like it's frowning? Well, it's going to be from B to C. So it looks like our only answer choice is going to be answer choice B. Okay, a related rates problem, very good problem. I would always start out by sketching this. And we have the traditional ladder is propped up against the wall. And of course, I cannot draw worth anything, but y'all get the idea. The ladder's 25 feet long. And it's 7 foot up off the ground, and we can do the Pythagorean Theorem and find that this is going to be 24 feet. Foot, I don't know what foot is. So let's see. We're also, the ladder is sliding down the wall at 3 feet per second. So that's going to be -3, or not feet per second, feet per minute. So here, -3 feet per minute. And I want to know, well, what is the rate of change of the ladder moving out? So dx dt is what we're looking for. So we can set up our Pythagorean theorem. X squared plus y squared equals z squared. And so we have 2x dx dt plus 2y dy dt equals 2z dz dt. And we can go through and fill in 2z dz dt. Whew. All right. So let's cancel some of our 2's and let's start filling in our values. Well, our x we know is 24. We do not know dx dt. That's what we're trying to solve for. And our y value, let's see, was 7 times the rate of change of y is -3 because it's sliding down the wall, equals, well, I know this side is 25, but it's 25 times the rate of change of the ladder. The length of the ladder is not changing, so it has to be 0. So here we're going to solve for dx dt, and when we do so, we see that dx dt is going to be equal to 21 over 24, which most days should reduce to be 7/8. So answer choice D. And for the last problem on this quiz, we're told a couple of things about a horizontal and vertical asymptote. The first thing we're told is we have a horizontal asymptote, y equals 2. So we have to remind ourselves, well, what does calculus say about that? Well, if we think back, that is our infinite limit. So the limit as x approaches infinity of our given function ax plus b over x plus c, well, if my horizontal asymptote is 2, then that means this ratio, this is what we called in class a Betsy. Bottom equals top, so it's the ratio of coefficients. So that tells me that ax over x has to be equal to 2, so therefore we see that a is 2. Now we're also told that our vertical asymptote is equal to -3. Well, a vertical asymptote is found by finding the denominator. X plus c equal to 0. So x equals -c, but x is also equal to -3, so we see that -3 equals -c, so c is 3. And if we need to find a plus c, well, a plus c is going to be 5, so that tells me that our final answer should be answer choice E.